Good afternoon, my liberal arts math students. Missing you all terribly. Hoping you all are safe and well as your families. We're going to get through this one way or the other. If we do have to do this the whole rest of the quarter, then we will. Hopefully not. I'm hoping we'll get back together, but for now this is what we're doing, so let's make it happen. What I've decided to do now is I'm going to go to section 14 under integrated review. Okay? Not chapter just 14 by itself, but chapter 14 integrated review. And I want you to click on there. We're going to skip past the first two sections. The first two are just multiplying and dividing whole numbers. I'm confident you all can do that. I'm not concerned about that at all. I want to instead go through the other four sections in here, which I think will be of value to you to make sure they're reinforced and you're ready to handle those in the future. All right? The first one is probably the easiest. I think this is a great way to get started in this way of doing things. It's lesson 14.R.3, tests for divisibility. Okay, tests, how do you determine whether a large number is divisible by smaller numbers? It's pretty easy, especially if you just learn the rules I'm going to teach you. Okay, before we get into any work, here's the rules I want you to understand. We're talking divisible by 2, 3, 4, 5, 6, 9, and 10. Those are your ones you're concerned about. Okay, they're right here in this very first problem. 2, 3, 4, 5, 6, 9, and 10. How do I know if a large number is quickly divisible by those numbers? And I'm going to teach you the tricks to all of them. Number 2 is the easiest one. For 2, and I would suggest you write these down so you have these in your notes. Okay? If it's divisible by 2 if the number is even. Number is even. Very easy. Okay? So in this example, this first question, the number is 123. Is that an even number? It is not. It ends in a 3. So it is not divisible evenly by 2. Okay? The next number, the number 3. The test for the number 3 is add the sum of the digits. Okay, so add the sum of the digits in the number. The number here, you probably can't see it. It's too small on your screen. It's 123. Add those 3 digits up. 1 plus 2 is 3, plus 3 is 6. Is 6 divisible by 3 evenly? Yes, it is, twice. So if that's the case, then 123 is also divisible by 3. Okay, the end. Number 4, if the last 2 digits are evenly divisible by 4, then the whole number is divisible by 4. The last 2 digits of 123 are 23. 23 is clearly not divisible by 4, so this one is not divisible by 4 either. Okay, 4 is divided into last 2 digits. Okay, I'm going to erase that. Presume you've written that down. Okay. Number 5, very easy. Number 5, if the number ends in a 5 or 0. That's it. 123 obviously doesn't end either one of those. It is not divisible by 5. Number 6, if divisible by 2 and 3, because 2 times 3 is 6. If a number is divisible by 2 and by 3, it is also divisible by 6. We already said it was not divisible by 2 because it's not an even number, so it is not divisible by 6 as well. Number 9 is the exact same thing as number 3. You add up the digits. If the sum of the digits is divisible by 9, then the whole number is divisible by 9. We did this earlier. 1 plus 2 is 3. 3 plus 3 is 6. 6 is not evenly divisible by 9. So this number 123 is also not divisible by 9. Lastly is number 10. Number 10 is like number 5, but even easier. If the number ends in a 0. Okay? Clearly it does not end in a 0, so this number is not divisible by 10. Simple. Alright, so let's work through some problems. We just did this one. It says, use the test for divisibility to determine which numbers divide evenly into the given number. I'm going to switch the number. The number is now 509. I'm going to switch it again. Let me see. Alright, there we go. 198. The number is 198. So, number 2, is it an even number? Yes, it is. For the number 3, what's the sum of the digits? 1 plus 9 is 10. 10 plus 8 is 18. 18 is divisible by 3 6 times. The number 4, can I divide the last 2 digits evenly by 4? Well, 4 goes into 9 twice with a remainder of 1. 18, no. Okay, if you need to use your calculator, that's fine. Just do 98 divided by 4. Okay? Divisible by 5. Does it end in a 5 or a 0? No. Divisible by 6. Is it divisible by 2? Yes. By 3? Yes. Then also by 6. 9. Add up the sum. 1 plus 9 is 10. 10 plus 8 is 18. 18 divided by 9 is 2, so yes. And 10, does it end in a 0? No. So the correct answer here is 2, 3, 6, and 9. 2, 3, 6, and 9. Yes. Next. 78, 698. I'm not going to bother with this at all because I think you guys get the concept. Okay? Use the same rules. Skip. I'll do one more as we have a bigger number. 799,990, or I'm sorry, 799,090. Okay? Is it divisible by 2? It ended in a 0, so it's even? Yes. By 3, we add up the digits. 7 plus 9 is 16, plus 9 is 25, plus 9 is 34. No. We also know by now it's not by 9 either, because if it's not divisible by 3, it's definitely not divisible by 9. Okay? 4. The last 2 digits, 90 divided by 4. Is that even? No. 5. Does it end in a 0 or a 5? Yes, it does. 5 is good. 6. If it's divisible by 2 and by 3, it's not. So 6 is out. And then 10, if it ends in a 0, which it does, it's divisible by 10. So 2, 5, and 10 are my options here. 2, 5, 10, yes. Next. All right. The next thing they like to do in these sections for you. Determine whether 18 divides the product of 6 times 10 times 11 times 11 times 11. If it does divide the product, then find the quotient. If it doesn't, indicate the smallest factor that should be included in the product to make it divisible by 18. So when you look here at these numbers, this is a little tricky, but it's kind of a little fun. I want you to think of this, you're a sleuth, you're a detective, looking at the evidence, and how can you make the evidence fit? Well, you know that when you look at here, 6 times 10 times 11 times 11 times 11. Well, I know I have a 6 here. I know that 6 times 3 equals 18. So I have the 6 already very obviously in this list of numbers. Is there a factor 3 hidden in any one of these other ones that I could pull out? Is there 3 times something that gives me 10? No. 3 times something gives me 11? No, 11's a prime. So, right now, this number, 6 times 10 times 11 times 11 times 11, is not divisible by 18. It needs to have a 3 in there, and then it would be. So the answer here, does it divide the product? The answer is no. What is the smallest factor you need? It's a 3. Because 6 times 3 is 18. These are going to be a little tricky, but I think you'll get the hang of it if you practice it. Okay, that's always the key, practice. Determine whether 20 divides this product. Now I look here, I have 3 times 3 times 5 times 11 times 12. As you look at that list of numbers, are one of those numbers a factor of 20? In other words, does one of those numbers divide evenly into 20? The answer is yes. The 5, right? 5 times 4 gives me 20. I have the 5 here. Here's where it gets a little bit more tricky. There's no 4 here, so right away you're saying, no, I don't think it is. And you'll be right. But remember, it says what is the smallest factor that should be included to make it divisible by 20? Notice this. 5 times 4 can be rewritten as 5 times 2 times 2, because 2 times 2 is 4. Do I have a factor here that has 2 in it? And I do. It's 12. 2 times 6. So, in order for 20 to be divisible, I've got to have 5 times 2 times 2. I've got 5, and I've got 1, 2 here. Okay? Now look, oh, you know what? I'm making this harder than I need to. Ignore that. Making this way harder. I have 5 times 4. I said the 5 was here. Is there a 4 hidden in here anywhere? The obvious is no, because there's a 3, a 3, a 5, an 11, and a 12. But you know that 4 times 3 gives you 12. Okay? So I have the 5 and I have the 4. The answer here is yes. Okay? 20 is divisible into this because there's a 5 and a 4 here. Does it divide the product? It does. Now, it's going to ask you now, what does that equal? I know you could do this very quickly with a calculator. And I'm not going to be there in front of you to make you do it differently. I'm just going to encourage you, though, to challenge yourself a little bit first to see this. If you want to know what this long number is, 3 times 3 times 5 times 11 times 12 divided by 20, you can make your life a little easier by crossing out the common factors between the two. 5 times 4, I can cross out 5, and I can cross out 4. And now I have 3 times 3 times 11 times 3, okay, which is 27 times 3, which is 303. If I did the math right in my head, and I may not have, let me see, 307 is the answer. And I'm not right there either. 3 times 3 times 3 is 27 times 11, 270, 297, sorry. There we go. All right. We're going to have more to come. I know it confused you. We're going to have some more to come back to practice, okay? Determine a set of 4 numbers that are divisible by the number shown. So the number they've given us is the number 3. They want us to look at this list of numbers and find 4 of these numbers divisible by 3. So you just remember in your mind, what is the shortcut to know? Add up the digits. If they're divisible by 3, then so it is. What some of you are probably going to do now is pull out your calculator and put all these in until you hit this by 3 and find your answer. If you do that, that's not what I want you to do. I want you to do the shortcut this way. This is 4,975. Add those up. 4 and 9 is 13, and 7 is 20, and 5 is 25. No. This is 510. 5 plus 1 is 6, plus 0 is 6. Yes. 9,578. 9 plus 5 is 14, plus 7 is 21, plus 8 is 29. No. 5,336. 5 plus 3 is 8, plus 3 is 11, plus 6 is 17. No. 2,395. 2 plus 3 is 5, plus 9 is 14, plus 5 is 19. No. 3,918. 3 plus 9 is 12, plus 1 is 13, plus 8 is 21. Yes. 3 times 7 is 21. 7,888. 7 plus 8 is 15, plus 8 is 23, plus 8 is 31. No. And I'm done because I need to have 4, and so these two must also be the only ones I have left. Okay, next. All right, determine whether 18 divides the product of 2 times 3 times 3 times 5 times 11. All right, so I'm looking here to see what I see. Let's factor out 18. 18 is 6 times 3, which is 2 times 3 times 3. Right? 2 times 3 is 6. 6 times 3 is 18. So we're doing a factor tree here. That's what I'm going to call this. I didn't do this in the last one. We're going to do a factoring tree. You can do 6, you can do 3. 3 is done. 6 goes to 2 and 3. So I have 2 times 3 times 3. Do I have 2 times 3 times 3 here? I do. Right here, right here, and right here. So the answer is, does 18 divide the product? Yes, it does. It's then going to ask you, what does it give you? Well, notice what I just did. I went up here, I'm going to write these bigger. I have 2 times 3 times 3 times 5 times 11. And here I have 2 times 3 times 3, my factor tree of 18. So I cross out common factors. 2, 3, 3. I have 5 times 11 is 55. Okay, so that long number divided by 18 is 55. All right, factor trees, that's what we need to do. I should have said that earlier. Here we go. Factor tree, is this number divisible by 24? 24, just think of the first two things that come to mind that multiply together to give you 24. I'm going to say 6 and 4. 6 is 2 and 3. 4 is 2 and 2. So here's my factor tree for 24. 2 times 3 times 2 times 2. 2 times 3 is 6. 6 times 2 is 12. 12 times 2 is 24. So I'm looking for these factors up in this line of numbers. Can I factor any of these numbers? 3, it's this. 3 times 5 times 7 times 11 times 11. Those are all prime numbers. They're all prime. You can't factor them. Okay? So, the only common factor is 3 and 3. So what I'm left with is 8. Do I have that up here? Any 2's at all? I don't. Is this divisible by 24? It is not. What is the smallest factor I need to put into there? It is what's left over here. 2 times 2 times 2, which is 8. Good, I was hoping it gives me one more. All right, determine whether 84 divides this product. 7 times 7 times 11 times 12. Times 7 times 11 times 12. Let's do factor trees. 84. Not a real common thing that comes to your mind, but it's an even number, so you know it's got to be 2 and 42. This is 2 and 21, and this is 3 and 7. So I factor tree this out to 2 times 2 times 3 times 7. That's 84, the factor tree. 2 times 2 is 4, times 3 is 12, times 7 is 84. So now I got to look at my numbers up here, and if I can factor any of these, I need to do the same thing. I have 7, that's a prime number.
times 7, another prime, times 11, another prime, times 12, which is 3 times 4, but 4 is also factored to 2 times 2. So I've done a factor tree here as well. So I have 7 times 11 times 3 times 2 times 2. 2 times 2 times 3 times 7. Do I have all of these factors in my list? I have a 2, I have a 2. I have a 2, I have a 2, I have a 3, I have a 3, I have a 7, and I have a 7. It leaves me with 7 times 11 left over. So the answer is yes. What is the product? The quotient, it is 7 times 11, which is 77. Determine whether 20 divides the product. 5, 7, 10, and 10. So 20, factor tree, 5 times 4. 4 factors out to 2 and 2. So factor tree of 20 is 5 times 2 times 2. 5 times 2 is 10, times 2 is 20. 5, 2, 2. So here I've got 5, 7, 10, and 10. 5 is a prime, it doesn't change. 7 is a prime, it doesn't change. 10 is 2 times 5. Another 10 is 2 times 5. So I've got this all factored out to prime numbers and prime numbers. A 2 here, a 2 here, a 2 here, a 2 here, and a 5 here, and a 5 there. So 20 is divisible into this number. What's left over is 5 times 7 times 5. That's 25 times 7, which is 375. Oh, there's my math on my head. Failing me now. What are you wrong? 25 times 7, because 25 times 8, oh, 175. Let's try that again. There we go. You'll use your calculator instead of your head. All right. Last one. One more of these to get the picture. Determine whether 9 divides the product 2 times 3 times 3 times 3. Factor trees. I have 2 times 3 times 3 times 3. They're all prime numbers. I can't factor it. It's done. Divisible by 9. 9, factor tree is 3 times 3. 1, 3 here, 1, 3 there, 1, 3 here, 1, 3 there. Is it divisible by 9? Yes, it is. They had all its factors in it. Left over is 2 times 3, which is 6. That's it. Does it divide the product? Yes, it does. By 6. The end. Great. All right, so that is the end of the lesson. I hope it's fairly simple and straightforward. I'd like you to start working on this. I'd like you to get certified by Monday. Okay, you're going to start tomorrow, Thursday. What is the date for that? The 19th. Today is Wednesday the 18th. So certified by tomorrow. No, certified by Monday, sorry. Monday the 23rd. Yeah, Monday the 23rd, please get your certification done. You guys kind of have it easier than my other classes because you have this book and the certification. You're going to be easier to move along than the other ones. So please, I'll post that up. Let's get your certification done. Looking forward to, we'll do a live chat together on Monday. Live chat Monday, okay? Be safe, be well. Talk to you soon.